So good morning. Today I'm going to talk about from monitoring sucks to monitoring love, and sadly also back. It helps if I turn this on. For those who don't know me, I'm Kris Buytaertrt. I've been doing this conference thing for over a decade now. I started my career as a software developer, mostly writing software in all kinds of crappy languages, Perl, PHP, Python, C. And then I kind of became an operations person out of necessity, because I was the only one knowing how to rack a machine and cluster it and scale it and deploy it and all that stuff. You might know me from my blog, Everything's a Fucking DNS Problem, and JP will solve it. My role these days is I'm the CTO at NETWAYS, which is one of the larger open source consultancy companies in Europe. We have offices in Belgium, the Netherlands, Czech Republic, Ukraine, and there's more coming, I've been told. And besides organizing conferences myself, like Config Management Camp and DevOps Days and all that kind of stuff, a lot of the work I do is evangelizing DevOps, getting operating systems people and developers closer together. What I'm going to do today is give you guys it's going to be opinionated, you can trust that, talk about the current state of the open source monitoring landscape. But what I also want to do is that I don't know everything. And I know that there's a lot of smart people in the audience that know a lot of stuff better than I do. And I'm really open to feedback if I miss something or if I can integrate something better. I hope to learn from this talk. So why do I talk about monitoring? Well, I talk about DevOps. And for a lot of people, DevOps is about culture, lean, automation, monitoring and measurement, and sharing. And that's what those two guys in the back figured out when they were doing their podcast DevOps Cafe. That's Damon Edwards and John Billis. And then Jin Kim put in the lean influence. So monitoring and metrics and measurement is something of the core components of what the DevOps movement is about, next to automation. And you'll see that those fit together likely. But if you look at a lot of organizations, you see that nobody spends time on actually doing monitoring. There's no budget, it's too late, they deploy a site and they forget about the metrics, it goes down and the customer only notices it, because people just don't think about it upfront, just like they don't think about security updates or think about scalability. It is something where operations people, security people, and developers need to think upfront when you start a project. This is something we need to take into account. So monitoring sucks. If I go back in history, seems like yesterday, but it's not yesterday. Back in 2008, we at NETWAYS decided to write a paper for the Ottawa Linux Symposium, where we started comparing back then the state of open source tools in monitoring. And we started with a large list of somewhere around 20 to 40 tools, and tried figuring out what do we really want from a monitoring tool. And we came down to a couple of tools that we really wanted to investigate in. Back then it was Nagios, Hyperic, Xenos, Zabbix, OpenNMS, Groundwork was in there, and I guess that was it. Did I say Hyperic? Yeah. And the conclusion we had back then is that there was a lot of bloated Java tools, which people didn't want to run on their systems because, well, if the footprint of your memory, of your monitoring system is bigger than your actual application, for a lot of people that didn't make sense. A couple of those tools were heading into the open core world. Xenos back then was really changing its license and taking a lot of the interesting stuff into open core, and we were an open source company, so we really didn't care. And for some of the other tools, if you started adding more than 200 nodes, you actually needed a full-time DBA. Zabbix was one of those. Cacti was one of those. And that's also not something you needed. If you spend more time in actually managing your monitoring system, then you have the benefit from it. And if your database goes down, your monitoring system goes down, you have some issues. So what we concluded then is that what most people really did back then with the advent of tools like Puppet to support configuration management and to support automation, Nagios was still the only manageable tool at scale out there. And, well, we had a vote on the internet, and this was what the community said back then. About 27% said Nagios, some 28 Xenos. Hyperic was in there. Hyperic, Groundworks. A couple of those tools, they're still around, but nobody hears about them anymore. Anybody here running Hyperic? Heard of Hyperic? Okay, 5 people. You were in my talk like 5 years ago. I think actually Tom de Koopman gave that talk here in 2008 or 2009, I don't remember. All right, that's a pop-up for a Hangout, cool. So we have a team Hangout now. So that was 2008. And then somewhere in June 2011, John Vincent loses on Twitter, said monitoring sucks. And the whole Twitter ecosystem started crying, yes, monitoring sucks. He wrote why it sucks. And the first thing he said in that blog post is, monitoring is awesome, metrics are awesome, but we still kept calling it monitoring sucks. And what he didn't like about it is that he had his hand tied. So he had to jump to all kinds of hoops to set up a monitoring platform that worked for him. And that he had tools that were giving him metrics, but not giving him alerting, and giving him great dashboards, but not giving him the ease to configure them. And fundamentally, that he did not actually have a choice, that he was, like we concluded 3 years before, tied to that one system. He missed out on a couple of awesome tools back then, because he hadn't realized that the original NETWAYS was forked, and that there was a couple of things. Well, at least I assume he didn't, because otherwise he wouldn't have said it sucked that hard. So to me, the monitoring sucks movement is kind of a sub-movement of the DevOps movement. If you want to know what kind of tools are out there, part of what that group of people started doing was start to create a GitHub repository where we were listing all kinds of monitoring tools, small and big, that we ran into. But there's more reasons why people say monitoring sucks. Manual configuration of your monitoring tools. Your monitoring platform absolutely not being in sync with reality. There's like 5 nodes added yesterday, and they're not in the monitoring system yet, because nobody added them. A lot of those tools just monitor the hosts, not the actual services. Well, yeah, they monitor the service as they monitor Apache, but not the actual business functionality running on that application, which is what the end user really cares about. It's chaotic, config is spread all over the place, there's no structure in it, and well, maybe one of the biggest problems, alert fatigue. People just stop looking at their monitoring system because it's constantly red, and they're used to it being red. So whether there's 15 checks in red or 25, there's no difference anymore, because people just don't react to the alerts anymore. And that's probably the biggest problem with monitoring in the last couple of years. So we decided to forget about a bunch of tools. We decided to forget about tools which have absolutely no API to manage, that have a strong focus on a GUI. Well, unless there's always the edge cases. And if we look what we really want from a monitoring tool is we want something that is back to the Unix philosophy. I need to replace my batteries. We want something which is small, which hooks different small components together, where we have tools that do collection, we have tools that do transport, mangling of the data, we have tools that do storage of the data, we have tools that do the analytics of the data, we have tools that do acting and alerting, and we have tools that do the visualization. And with this in place, you can build best of breed. And that's how, in a way, we came back to monitoringlove. And monitoringlove actually is the hashtag we started using after Ulf Mansson did an awesome Ignite talk at DevOps Days Rome in 2011. And it was for a lot of people the area where a lot of new tooling started. Monitorama started being organized. We at NETWAYS did a 2-day monitoring hack sessions after FOSDEM, where we had a bunch of people sitting together figuring out how these things could work together and what kind of tools we needed to build to solve that. And then we came up with these kind of architecture pictures where... Are you laughing now? Oh, you're in for a good treat then. So we came up with these kind of architecture pictures where on the left you have data collection. We have, now I need to get closer, we have Java, which exposes JMX, we have Apache and Tomcat logs, we have collect D getting metrics, we have not just clients, we have Puppet reports, and we sent them over a variety of protocols. For example, JMX traffic goes over JMX. We store it in either OpenTSDB, Ganglia, Graphite, or we take logs and ship them with Logster and then get them to Graphite, Ganglia, whatever, because they all had inputs and outputs to everything. We get, for example, back then, because this is a really old setup, you used to collect the carbon plugin to ship your collect D metrics to Graphite, stuff like that. Or you used the Apache logs, ship them to our syslog, then to a Logstash shipper, because that's what happened in those days. You had a shipper on the machines to Logstash. Then there were tools like Esper, which did some kind of event correlation. Never seen it actually work. From Logstash, you shipped to StatsD, back to Graphite. You had some tools that sat on top of Graphite that could do alerting, like Tattle, and eventually everything came back to Node.js. So, yeah. Kind of what monitoring looked like. If you have a software project and you have a large enough organization, definitely the architecture of your software project is going to look like your organization. I don't know who found out that rule, but it's pretty much truth. So about 6 months later, we added Riemann, we added Diamond, we added PacketBeat, we had queuing systems. Well, people used Redis as a queuing system. We had different backends. We had some more storage engines, some different dashboards. And at some point in time, I think that was actually with this slide, but some guy came up to me and said, "We're using all the tools in your slides. And guess what? Monitoring still sucks." So that was the point where I figured out that he had not connected any of them, and he was just looking at all of the tools as isolated islands and not glued them together. So he did not get any value from that. So what does work then? I've been paid to put in this slide. No, honestly, I mean, there still is a bunch of tools out there that do work, that do give me ease at mind where we can work together. At Puppet Camp Düsseldorf, I actually said that I think it's illegal in Germany to speak about Node.js these days. But the fact is that this is a really good alternative. It is an open source fork, like a lot of projects, where there's a community who wants to contribute, who doesn't get features commuted back upstream. You do the right thing and you actually fork. I keep running into these guys. I don't know how it happens. I run into these guys at the weirdest places in San Francisco. So it's either that or they're stalking me. And everybody talks about it. And there's a Puppet module for that. But if you look at these kind of tools, monitoring your infrastructure, and you're doing something which is infrastructure as code, if you live in a Puppet world, but you can translate this to whatever config management tool you want to use, what you should do is actually automate all of this. You should have your nodes who are exporting the resources you're running, or using data bags, or actually having a catalog where in code you define, this is what I'm running on this server. And then you upload that somewhere. In Puppet, that means exporting a resource to the PuppetDB. And then on the other side, you have your monitoring system, which collects all that data. And once you deploy the 25th web node, your config management system will know, hey, this is a web node. For every web node, I'm going to reconfigure the monitoring system. So it exports that data again, and the collector, which then is a monitoring system, gets exactly the right data. When you remove the node, you have the same workflow. It's removing config from a machine that's not being monitored anymore. And for a lot of people, that part is actually what brought back the monitoring love. The fact that we didn't have to fiddle in config files anymore. We didn't have to work with bloated GUIs that wrote config files in a way that we didn't them to write. No, it was now our code, which we generated, that configured our monitoring system at scale. And it didn't matter if we had 200 nodes to configure or 5,000, because that's what those config management tools are for. So that's how we ended up having monitoring love again. So who saw Ulf Mansson's talk? I knew the hand was going to rise. And what was that talk about? It was about?
Basically Sensu.
It was a talk about Sensu, because Ulf had his kids draw lovely pictures because he was in love with the new tool he had, Sensu. And up till yesterday evening, I said that all the use cases I had seen before for Sensu were in large, scale-out, elastic platforms, which is where I think it really is an awesome tool. And this is Europe, so we don't do cloud, so we have static platforms. Who does cloud? Who's running on Amazon these days? I actually was expecting Taurus to raise his hand, because he's American. Because that's what that were two people raising their hands. If you do the same question in San Francisco, there's two people not raising their hands. And that's a culture difference. A lot of the people that I know that run Sensu do it on Amazon, because they have nodes disappearing, nodes reappearing, and if you do that on a frequency lesser than 5 minutes, it's going to be really hard to do that with Nagios or Ikenga. It works, but Sensu is a much better fit there. But then I was in Stockholm, I think for the DevOps meetup in Stockholm in January or February, and I was walking to my hotel with Ulf. And he was talking about how many metrics he had currently, how many checks he currently had on his setup. And he was talking about, well, I have this clustered RabbitMQ, and there's 10,000 messages per second going through, and guess what? There was a whole new challenge there. He's still happy with monitoring, but it's not that this is the magic tool that solves everything. There's new challenges when you reach certain levels. So to me, really, it's really automation that brought back the love. It's the fact that I don't need to do this thing manually anymore. I can actually have my machines configure themselves. And there's a lot more love that happened. Tools like CheckMK will allow you to do really good hardware detection that do multiplex and do trend forwarding. And they're also helping to contribute to the law. But I actually hate that, because there's other parts in this. It does auto-detection of the service running, but not of the actual application. It's, once again, one of those tools that wants to write my configuration file for me, which I don't like, because I'm actually fully managing that config file from a config management platform. So I need to figure out a way to mix and match certain parts and template things, and let CheckMK generate a part and do part in config management, and it's starting to become a mess again. Because in a way now, I've lost my single source of truth. I lost the fact that my config management system is in charge. And it then becomes the point also, if you're doing service monitoring, that you're monitoring a service. And what is valuable when you're running an organization? The fact that Apache is serving a nice, hello, this is the CentOS page, your Apache is functioning perfectly, or the fact that there's actually a billing engine there where a customer can put his credit card and send you money. I like the second. So that's what I need to monitor, and that's what a tool like CheckMK or any other thing that does auto-detection is never going to figure out, unless you teach it. So when you are working with software developers and they are delivering a service, you see that when they go through an evolution of going to become more agile, doing software development in sprints, in 2 weekly sprints, they start introducing this thing called a definition of done. It's a set of rules which they agree on that the work they promised on Monday, 2 weeks later, they can actually check it off as being done when these, and these things have been done. And if you see those teams evolve, you see that they, after having software works, software builds, it's in version control, we have a test, we have removed the test, we've added the test again, they end up having monitored and in production as a part of their definition of done. So this is where we have the operating system people and the developers work together. Because now we're actually talking about monitoring a service. And when you go into that discussion, we're going to need to define how we figure out if a service is still healthy. So it's monitored and in production. Now, I'm one of the guys who doesn't like the definition of done, because software development is never done. You also have to make sure that you do security updates, that you are keeping the platform fast enough, that there's failover in place. And to me, there's a new definition of done people should learn about. So what's the obvious next question? How do you kill off your users? No, I actually want to know when my last end user is dead, or more when there's no traffic anymore. So I need to really start measuring all the things, monitor all the things, and measure all the things. And measure all the things also include actual usage. That, by the way, is also one of the most important things when you're doing upgrades and migrations. If you can predict when there's no users, you can seamlessly do an upgrade with no traffic interruptions. I don't want to count how many organizations I'm working with that do an upgrade, as in we're shutting down a firewall now. Okay, we're waiting 10 minutes. Now all sessions have timed out. Now we can do the upgrade. How many users did you have? We don't know. So we need to talk about metrics. We need to talk about collecting data, getting, for example, deploy statistics. Each time we deploy software, I want to know what happened. For example, we use Graphite to send an event. We do a draw infinite, and we map this. These are actual Puppet and Hero. Well, no, not the Hero. These are actual Puppet deploys. We map those Puppet deploys to the metrics on the platform, so we can see that the changes we introduced, they actually impacted our monitoring, or they actually impacted the performance. And you can start measuring all kind of things. Time to deploy from code commit to production, deploy frequency, life cycle, all that things. Or you want to get metrics from your platform. And then you start using tools like CollectD. And you get those metrics out there at really high intervals, and you ship them to Graphite. You get this kind of awesome metrics. Graphite is awesome in the way that it exposes an API to your developers again. And it allows them to build a self-service platform, a platform where they can, for example, build their own dashboards using a tool like Gdash. And this is actually a real code snippet from developers we were working at who were really interested in their MySQL metrics, and they build their own templates to have all the slave metrics, all the monitoring from the metrics they collected and they themselves sent to Graphite. They have these in. That's not a work in progress anymore. That's actually already obsolete because we moved forward. But they could build templates with Graphite, put them in a source control Gdash, put them in a source control repository, and have a pipeline push that through production, a tested pipeline. So then they built these things for themselves. This is already looking much better than this, right? The trend we've seen that in all the tools that we started using 3 to 4 years ago, there's a lot of improvements in user functionality in front user interface. Because where Gdash was the tool that we were cheering about 2 years ago, these days a lot of people are using a tool like Grafana, which is the next generation. We've also noticed that a lot of the things which used to be server-side is now going to be client-side. This is actually parsing the JSON output from Graphite and pulling that in and rendering it in the browser. So you can get much more fine-grained metrics in your browser faster. So Graphite has evolved. There's new dashboards, but there's also new engines because people have been running into new challenges. Carbon wasn't what they really wanted, so now there's stuff like InfluxDB and there's Cyanide, where people are trying to find new borders. So now we have graphs on usage, on system usage, on things our developers have told us they want to use. What do we need to do now? We need to figure out a way to alert on those graphs, because if there are no users anymore for a week, we need to know about it so we can actually decommission this. So this is a slide I've been using to teach that to people on how you could do such a thing with a tool called, and that they do. Oh, cool. I should have reread my slides this morning. Check Graphite, which the link was down here somewhere. And one of the things you could do there, for example, is export your Java metrics, because the use case we usually teach is how to monitor if you're working with queuing systems. It's normal that there's sometimes a hiccup in a queue because some endpoint is gone. And they keep stuff on the queue, but what you want to know is the queue being flushed frequently? Aren't there too many messages staying on the queue for too long periods? So it's fine if there's 200 messages on the queue. It's fine if there's 2,000 messages on the queue for the past half hour. But it's not fine if there's 2 million messages on the queue for the past half hour. Then you have a problem. And that's the things you kind of can figure out by monitoring and alerting on graphs. So you export your Java metrics. That's Puppet exported resource, for example. You send them to GMX trans then sends them to Graphite. You configure an RP check that checks on Graphite the value of the graph over the last half hour, and that's an export you do again to an Agile check. So on the host machine where the application is running, that's where the actual check is running. No tricks with fake host, no tricks with doing stuff around. And then you get those things with Puppet exported and imported. And then you have a nice check on, hey, so on that queue, on that particular queue, there's 20,000 messages for the past half hour. Maybe you should look into this. So that's all fun if there's only one machine with one queue. But what you really want to do is alert on aggregates. Alert on there's this 20 queues, and if the sum of the messages on those 20 queues is larger than this, then we have a problem. Or if the traffic flowing over this network in total is over this threshold, then you have an issue. And a lot of people that I've talked to, and actually one of our customers uses this tool for that. Who knows what this is? Who likes Riemann? Okay, those four we need to talk. You need to explain what the fuck this is about. Because to me, this is distributed top. I've been trying to get a hold of it, and I don't get it. I've got it up and running at one customer, and those people are still looking at it, and they wanted me to implement it because it looked awesome. And this is not, to me, what awesome is about. This is going back to me to ganglia back in the days. That kind of looked like this, apart from the figures up there. So what we're doing now with tools like Riemann is that you get data from Riemann Health, which is a nice Ruby plugin you really don't want to look into. That sends that stuff to Riemann.io, and then you flush your metrics to Graphite again. Because Riemann is really not meant to do long-term storage, but a lot of people flush their metrics and alert back to Graphite. As I said, I still don't get it. I see it mostly as a way of doing a distributed top in the screen. Of those four, who actually likes Clojure? Nobody. Why are you using Riemann? Why do you write config files in Clojure if you don't like Clojure? A lot of improvement to me came when we switched from the Ruby-based Riemann Health plugin to actually sending stuff from collectd, and then output everything to Graphite, because then it started making sense again. But I'm probably missing some parts here. I've been looking at people who have good, solid experience with Riemann to show me what it really is about, because there must be some magic in there. So we have these graphs. We have a lot of data now. And we need to go from a point where we now have tens of thousands of graphs and metrics to actually getting knowledge from that. So this is what people do. The guys over at Etsy figured out that they needed to be able to correlate events and figure out, show me, if I have a graph, they wanted to be able to tell to a system, show me all systems that have exactly this graph. because that's where probably the anomaly they just detected is also happening. They also wanted to be able to, based on the graphs they have, based on the patterns they have, predict the next parts. So that brings us to a way where now we're not only collecting them, but we're looking at people that are doing really interesting stuff with it, that are going back to machine learning and doing actual big data analytics on these graphs, on these data, on these time series databases. So we missed still a large part, right? We did some metric collection, we did some status collection. What's a big part of monitoring we missed so far? I know it's early, you're all still asleep. I'm sorry, can you speak up? Interpretation. Yes, interpretation. So interpretation is coming later, but Riemann is what I've been told. If you know closure, is what could do interpretation and aggregation too. But I've got more slides on that too. But there's another thing we are missing. What do you guys do with your log files? There is a whole lot of data in your log files. There's a lot of errors in your log files that if you would read them and if you would alert on them, you would get a much more stable platform. And one of the first tools that started helping us out, and one of the very, very first versions of that tool, was the Logstash web interface. Who still remembers this? So people didn't like that. So Rashid came along and built this. And that was the very first version of Kibana. This looks better, right? But some people still didn't like this, and it still wasn't good enough. So they used Greylog as a front end to Logstash, but there's a lot of more alternatives. If you look at today's ecosystem, I think there's 3 major contenders in the open source log and metric analytics tools. That's Greylog, the actual ELK stack, which today stands for Elasticsearch, Logstash, and Kibana. And the guys from Balabit have ELSA, which is built on top of Syslog NG, which is the short for the Enterprise Log Search and Archive. But I have to be honest, outside of Balabit, I've never seen anybody use this. Can somebody prove me wrong now? Damn, guys. So, one I use the most is the ELK stack because of this. I can get metrics and data from pretty much everywhere. And the scary part is that I updated this slides because the previous time I used it, it actually had a circle here on one specific input. And now it actually doesn't fit the screen anymore. And there's this weird column in between which is called codecs. That's new stuff. This thing keeps evolving. It has a zillion inputs, a zillion outputs. You can get your data from anywhere, filter it, and send it anywhere. And luckily, there is also a better dashboard now. This is, once again, one of these trends where we're pulling in stuff from the desktop, on the browser. Riemann, by the way, is also completely running in the desktop, but it's kind of slowish. Unlike Kibana 3 and unlike what Grafana does. Have you seen another trend? If you look at Kibana, Grafana, apart from the fact they all end on Ana, I just realized. All of these tools, for some reason, think that white or color on top of black is a good design. Lindsay Holmwood gave a talk again at DevOps Days, the 5th anniversary edition in Ghent. And one of the big arguments he made was that the best way to look at data and to learn from data is not white on black, but black on white. And apparently all of our current generation dashboards to monitoring tools still need to figure that out. There's another problem here, and that how many people in this room are colorblind? Nobody here. Weird. Usually there's like at least 10 to 15% of people who are colorblind, but it could also be that you guys don't realize it yet. So this is green and this is blue, right? Just to make sure. And if you see this on a street, stop, that's red. So black on white, no, it's something that we need to look into. Our user interfaces should not be fancy and designish. That's maybe a toggle we need to put in there for our managers because they look at it. But on a daily basis, we need to have something which actually is readable. So there probably is going to be a fourth generation of dashboards who are not darkly themed. So I thought about alerting, getting metrics from your system and all that stuff, getting data from logs. And there's, each time when we talk to large software vendors, they say, but yeah, but our people are using New Relic and they're using a lot of software as a service platforms to get data from the application. What does the open source world have to bring there? And there used to be a time where we pretty much said, well, it's about getting your developers to write codes and send their metrics to StatsD, or use the CodaHill libraries, or, well, there's so many things you can do to just send it to Graphite and learn from that. And they're all, yeah, but we're just going to sign up with this software as a service thingy and send our data in the cloud. Well, that's mostly what happens with overseas customers. Because in Europe, they're still like, I'm not going to send my data outside. So one of the really nice tools I came across was this one, PacketBeat. Is anybody using PacketBeat? One guy. PacketBeat is kind of trying to solve that. What they allow you to do is follow a packet from the moment it enters your network up to the point where you know this is how many database queries it actually generated. This is how many HTTP errors it generated. This is which APIs that actual HTTP request eventually calls in your complete backend. And they got color schemes right. You can get a lot of these metrics from different other platforms, apart from the mapping of an actual database response time and SQL queries to these RDHTTP errors mapped to the actual database. So there are a bunch of new tools out there that allow you to do it. By the way, there's Puppet modules for that. They might not be up to the last version, because when I built that proof of concept, that was like 3 to 6 months ago. But I'm with all the other stuff that you can find on my GitHub open for pull requests. But it's pretty easy to deploy it as in a proof of concept in like 2 to 3 hours if you already have an infrastructure which is automated. So application metrics, application monitoring now is something we can look into, which is suitable. But there's also something happening in the application landscape, which is supposed to be completely changing the way we are going to deploy software in this world. I found the logo that was closest to the actual Docker logo. Because I still don't understand the hype. We've been doing containers and that kind of stuff for ages. But now there's this trend where people say we're going to run a container which is immutable, which is going to be short-lived, and about 99.9% of the current application and the current enterprise applications don't fit that because they're stateful and they're writing stuff to disk and they can't do upgrades manageable. So there's a lot of room for teaching people how to deploy in these kind of environments. But there's also a new challenge into how are we doing metrics collection on those platforms? Are we going to get correlation of I/O usage and memory usage to containers? How are we going to do service health of applications if we don't have processes running inside the container? So we can go to the discussion whether you should have, it's not LSD, but the other thing Canonical just released. LXD, where rather than running run process in a container, they're running actually kind of a fully fledged operating system in a container, and that's their new thing. There you can actually include your monitoring in your metrics. But if it's the other way around, there's still a bunch of challenges. How do you monitor containers? How do you even know that you have healthy applications inside your containers? So you want to have a service registry, because that's what you then need to do when you're doing container-based deployments. And then you come onto tools like Consul. Again, who's running Consul here? That's an interesting challenge, because Consul kind of replaces a lot of functionality in Sensu. You could do pretty much the same with Consul and Sensu.
Yeah, but we are already running Surf as well, so that fits quite easily.
Yeah. Interesting. Yeah, you're running Surf because you're running Consul, because it's built on top of it. And what Consul was initially built for is service discovery. So I'm launching a container, and I'm launching an application, and it's going to be an Apache with this functionality, and I'm going to register that service to to Consul, just like you could do to Zookeeper, but in a much less complex way. And it's going to keep a key value store, and it's going to tell you, well, these 5 machines are running that service. It's pretty secure on a high availability level. You get random node-to-node communication to simplify the setup. For those who want to know, it's built by Mitchell Hashimoto, who did Vagrant and was doing a lot of other interesting stuff. And it once again uses those exact same monitoring plugins for health. So to figure out if that application is still working, it's going to be exactly the same check that you would use to have a Chinga check if it's still running. And then, like I said, it's kind of Sensu-alike. It's also the next chapter in JP's alternative DNS servers, because it also exposes all the services you register and all the nodes you register in its own internal DNS server, which then you have to jump through really ugly hooks to map that into your internal DNS zones and make them really usable. Stuff like why I needed to play with DNames and that kind of things. And if you add Consul template to that, you can also have that repopulate your Nginx configs as reverse proxies to the actual services. Nobody shouted systemd to me yet? Because this is kind of one of the tools that is trying to do everything, just like systemd. But fundamentally, what Consul really brings to me again is a DNS problem. But now I'm actually monitoring a service. So I have 5 Tomcat setups. We are exposing a service. There's a monitoring plugins check that does a HTTP check there. And the DNS for that service is now being exposed by Consul. So as long as those 5 checks are healthy, I get a response. So what if all my 5 nodes die? The DNS entry disappears. How do your application respond to suddenly a host that doesn't exist anymore, which doesn't resolve anymore, which is not what they're used to, because they're used to doesn't reply anymore. They're not used to doesn't resolve anymore. So we're back to actual DNS problem. But that brings you to the part where didn't we kind of solve a lot of these things, that we had tools that allowed us to do self-healing? I mean, we've been doing Heartbeat V2, CoroSync, Pacemaker, and all that stuff, where we had an OCF resource using, remember that one monitoring plugin we're using to check our service, but now not on the interval modules or Chinga does on every 5 minutes, but now every 5 seconds. Well, kind of the same I use as the monitoring check for my service registration. So I'm using that same check for high availability services. And this is where I've actually defined, I always want to have one of these services up and running. If it's not up and running, then restart it on another node. And we have that ecosystem in place already for, how long have we been doing Pacemaker? I don't know. I think I gave talks about Pacemaker in 2005. So over 10 years, probably. There's new kits in town, like Mesos and Kubernetes, that are doing this at cloud scale, well, at Docker scale. scale changes, the consensus modules between how they negotiate which nodes are active and how they deal with that has changed. But to me, a lot of the ideas on we're trying to build something which we're monitoring actively, and when something fails, we're going to repair it or relaunch it on another node, that's still the same. The ideas are still the same. It's only the complexity that has changed. And for those who have been thinking with me, then there's the next problem which is going to happen. Because now we've built this thing which we're monitoring on 3 levels. Well, 4, because we're also exposing metrics. And applications can connect to it. What's the next thing that happens? Your data center will fail. So we still need to figure out alerting. Well, your application will fail, CoreSync will fail. We check CoreSync if there's still all the active resources, and failure will happen. We need to prepare for failure. But we need to figure out data center failure too. So people send metrics to Nagios to send alerts. People send metrics to, this is actually, yeah, this is the slide where we get stuff from Nagios to Flapjack. So there's new kids on the block. Well, new old kids. If you haven't looked at Flapjack for the past 4 years, go look at it again. Because when Lindsay in 2009 introduced Flapjack at DevOps Days Ghent, the very first one, that was a tool which was kind of what Sensu does today. It was peer-to-peer networking, nodes recognizing each other, and building up a mesh network from where they could do alerting. Now it's something completely different. He reused the name, so it's again a DNS problem. He didn't have the zone available for something else. And now it actually is a tool that is going to allow you to build logic into who should I alert when and using which mechanism. It's going to take data from a lot of input sources, the 2 most used ones currently being an Ikinga flavor, sounds much better, and Sensu. And I think they're just released one of their major releases. Initially, they were mainly building towards Ubuntu, and trying to build it on a different platform was being a real pain because the omnibus ran off the boat constantly. But now they actually released packages for a bunch of other distributions. So that's one part. And then there's the other thing, because a lot of people use the proprietary SaaS vendor called PagerDuty. And I want an open source version of that, partly because sending SMSs to Belgian mobile phones from PagerDuty is as expensive as setting up an own platform. If I'm having an alert system that costs me about 25 euros a night because of sending SMSs from the States, that's really not a good idea. Yes, there's the app, but still. There's also this thing called OpenDuty, which is trying to build a PagerDuty open source platform. We have, if you search the GitHub repositories of all my colleagues, you'll find Vagrant boxes for both of those, but that's not really good. I'll put up links to where the Vagrant boxes are that do these kind of setups. So that kind of brings me back to monitoring sucked. We started loving monitoring. We're still not there yet, because my alerting strategy today is still in beta. It's 2014, I'm still running the same check multiple times at different intervals for different reasons. Service registration, high availability monitoring, and actually the next line is metric collection. So there's still a whole lot of stuff to do. But I love where monitoring is heading. We have much less false positives than we used to. We now have a maintainable infrastructure. If I deploy 5 new nodes, I know that they're going to be monitored. I know that I'm going to have the metrics. I know that the logs are going to be shipped and parsed. And I kind of love where we're going. But you need to integrate this with automation. So you need to talk about these things at the next conference you're all going to in Ghent, which is Config Management Camp. And I really, oopsie, that was too fast. Need new battery. Need new laptop. So that was pretty much my last plug. Who's in the same frequency as this thing? No, I get it. That's a slide I pulled from the slide as an auto forward because it was part of an Ignite. That explains. So yeah, Config Management Camp is a conference, one of the conferences I'm running in Ghent. But what I really want to see is a lot of content there on how people integrate, how they automate their monitoring tools with infrastructure as code. And that was pretty much my last slide. So yes, any questions? Not about DNS. No questions.
I guess you shocked them all, so.
Yeah, I guess it's an overflow of tools they've never heard of, which is kind of scary. Yes, one question.
Talking about that overflow, how big should a monitoring team be to get a grip on all these tools if you are using them not in an isolated way, but even in an integrated way, everything with everything?
Everything with everything, we have a stack which we built over the past 5 years, which we deploy on a bunch of customers. And the actual monitoring team, the guy who's in charge of that is one guy on a daily basis rotating. Building that platform, 2-3 years of engineering work, which is pretty much half, no, I'd say a tenth of what I know some of my customers spent on first purchasing a proprietary platform called Tivoli and then getting the license renewals and then having a 10-man team building something in Jython, which they hire Python engineers for that run off after 2 weeks because they're having to work on IBM tools. So to me, that's still in balance. All of this is open source. A lot of the stuff on automating it, yeah, I know you're a chef guy, but the Puppet manifests are out there. Patrick and I once started a project called Monigusto to actually have that on both platforms. And I know that for a couple of the projects that are in there, for example, for OpenDuty, Daniel Paulus, one of our Dutch colleagues, has the chef cookbooks written also. So that is an ongoing effort. A lot of people are contributing to automating different components. But setting up a platform like that, a new stack now, for a new environment, it's like half a day work. It's getting your backend variables hooked to the right platforms, and that's pretty much it. But it's not solved yet. It's not finished. And we're not using all of the tools. I mean, Reman is not in the platform, because I still don't get it. Right. Thanks. One more question. The problem to people getting tired of alerts is that when we have an alert, we immediately file an issue in Redmine to actually fix the problem. And we have one telco platform which we launched, I think, last year in April. No, this year, April. And our on-call engineers refused to actually take up that platform because they were afraid that it was going to be so much alerts in there that were useless. And because we're working with pretty much all of the platforms we built, there's a development platform, an acceptance platform, and production platform, also for the monitoring. The moment we started the acceptance platform, we saw the alerts coming. That moment we started realizing that these things we needed to fix on a platform level before we could actually move to production and sending out real alerts. And that kind of helps, alerting through your development pipeline, because then you learn what's going to fail. And if you don't do that, you end up, one of the other experiences I had, I was back in August this year, I came into an Amazon customer and he wanted me to set up a whole new monitoring platform. So I deployed him in his current Puppet Stack in a Kinga setup, and the first thing when it came up, it had like 500 alerts. Process not running, disk space full, because they were not monitoring it. And if you start from a broken system, there is going to be a large period of time you'd spend fixing the platform. But if you can actually go through a pipeline, have a development platform where you start adding alerts, and going that to acceptance up to production, it's going to be much more easy. At least that's my experience in doing so. So the first month that we ran in production with that platform, there were a couple of guys on call who put it on ANAG, and a couple of guys who just ignored it. And after 2 months, actually everybody is accepting the alerts, and we changed that platform to fully maintained now, where they're like, we haven't seen any false positives for 2 months. Because it goes through a development lifecycle. No. I don't have any experience with that. The guys over at NetC have built a tool called Ops Weekly, which I think I initially wanted to have in the slides, but forgot about. And that kind of does that. It also figures out, if I recall correctly, how much sleep the on-call engineers had on a certain night. Because that's kind of the healthy statistics you want. So yeah, Ops Weekly is one of the tools you could look into there. Any other questions? Okay. Well, thanks.